Welcome to this YouTube channel. We are still on differentiation, and the area we are concentrating on this today is on tangent and normal. Tangent and normal is a simple topic, or let me say it's a simple subtopic under differentiation. Just ensure that you relax and be optimistic as we proceed. The area we cover with introduction with illustration, because this illustration is very important. It will help you to have deeper knowledge of tangent and normal. And you know one thing in mathematics, when you understand the question, to solve it will be simple. Over time, students do solve questions that they don't understand. It's not possible to get correct answer when you are solving the question that you don't understand. Now, then we go straight to example on tangent and normal. We'll be able to do only one example. Then when we get to the back of the all the subtopic of differentiation, we're able to solve more challenging questions. Now, the first thing I want you to know that this one is a curve. Then this line is the tangent. You see that that line is tangential to that curve. So that line is the tangent. Then we have the third line. This line is the normal. And this line is perpendicular to the tangent. So the relationship between the normal and the tangent is like they are perpendicular. That is, the angle between them is angle 90. Then I want you to note something, that these three, the curve, the tangent, and the normal, they have a point of intersection. So the point of intersection of the three, as we proceed in this topic, you will see me using x1, y1. That point is the x1, y1. Now, there's some information I want you to note about these three. The gradient of the curve is equal to the gradient of the tangent. And the multiplication of the gradient of the tangent and normal is equal to 1. That is, when you multiply the gradient of the normal multiplied by the gradient of the tangent, you get -1. That one, in a simple way, you can say m1, m2 is equal to -1. In this material, I'm using m1 for gradient of tangent and m2 for gradient of normal. You are free to use m2 for tangent and m1 for normal. It doesn't matter. But for sake of clarity, so that you have deep understanding, you are not confused. In this material, I'm using, anywhere you see m1 is the gradient of the tangent, m2 is the gradient of the normal. And also note, gradient of tangent and the curve, they are the same. So m1 can be referred to gradient of the curve and gradient of tangent. Now, the equation of the tangent. This is the formula for the equation of the tangent. Y minus y is equal to m1 bracket x minus x1. That's y1 and x1. You know, we have talked about x1, y1. That's the point of intersection of the three, the curve, the tangent, and the normal. While m1 is the gradient of the tangent. The equation of the normal is the same thing as the equation of the tangent. The only difference is the gradient of the normal is m2. We want to solve an example here. Find the equation of the tangent and normal to the curve y is equal to 5x raised to the power 4 minus 7x squared plus x at x is equal to -1. I want to know something. That x equal to -1 is mean that the point of intersection of all the three. In a nutshell, I can say that x refers to x1. So when y is this, the y dx is 20x raised to the power 3 minus 4x plus 1. So when x is equal to -1, the y dx, I will substitute -1 inside the y dx, which is equal to -5. Also note that m1 is equal to -1. So when m1 is equal to -5, it means that m2 is equal to 1/5. Let me say a few things about this. m1, m2 is equal to -1. You don't need to do long calculation there. When m1 is a/b, m2 is -b/a. Let me repeat myself. When m1 is a/b, m2 is equal to -b/a. m1 and m2, both of them cannot be positive. Both of them cannot be negative. So you know that when m1 is positive, m2 is negative. When m2 is negative, m1 is positive. So let me use for a few examples. If m1 is 3/4, m2 is -4/3. When M1 is 2 over 7, M2 is equal to minus 7 over 2. When M1 is 2, M2 is equal to minus half. When M1 is 13 over 3, M2 is equal to minus 3 over 13. I believe that you master that either way. So when M1 is 1, M2 is equal to minus 1. So in this question, M1 is minus 5, then M2 is equal to 1 over 5. So when X1 is minus 1, you know, I told you that that X1 is like, that X is like X1. So to get Y1, we substitute that minus 1 inside the original equation. So when you substitute inside, Y is equal to minus 3. So therefore, our X1 and Y1 is minus 1 and minus 3. Now let us go to equation of the normal and the tangent. So the equation of the tangent is equal to Y minus 3 is equal to minus 5 bracket X minus 1. That minus 3 is Y1, that minus 1 is X1, and minus 5 is M1. So I can simplify it further. So Y plus 3 is equal to minus 5 bracket X plus 1. I can simplify it further by opening that bracket and collect like time. So Y is equal to minus 5X minus 8. That is the equation of the tangent. I want you to know something, that the method I use here, your teacher can use another method, but I'm trying to use a method that is as simple as possible. Now, equation of the normal. The only difference between the normal and the tangent is the gradient. So the normal is Y minus 3 is equal to 1 over 5X minus 1. You know, where minus 3 is Y1, minus 1 is X1, 1 over 5 is M2. So I can further simplify this also like this. Know that that 1 over 5 bracket X minus 1 is like X minus 1 all over 5. So I cross multiply to get that next line. So that one can also equal to this. I can simplify it further to be 5y plus 15 is equal to x plus 1. Then I collect like times. I have this as my final answer. 5y is equal to x minus 14. I want you to note something, that when the examiner give you the format for the final answer, you must ensure you follow that pattern dogmatically. But if you are not given, the question just says, what's the equation of tangent, what's the equation of normal, you can stop. Even you can stop at this level. You can just write it here and just stop. It is correct, but you can make it better by trying to factorize it and get your answer in the simplest format. So this is how far we are going to go on tangent and normal. I want to make the material to be very simple and straightforward so that you can digest and use to solve as many questions as possible. I want you to know that the understanding, the illustration I give you at the beginning, ensure you master it very well and use that understanding to solve challenging questions. I will still consider that after all the episodes so that you can see how this can be applied to challenging questions. I would like to tell you that try to subscribe to this YouTube channel. Click on the notification bell so that you can get notified anytime the new content is being released, and try to share with your friends.